Okay, so hello everyone. My name is Oliver, or Ols, and I work as a senior platform engineer at Sky Betting and Gaming in the core tribe. Sky Betting and Gaming run the Spotify tribal model with tribes, squads, guilds, and chapters. And some tribes are consumers of others' products as though they're essentially different companies. A bit of extracurricular for me. I'm one of the organisers of Sheffield Devops, which is a Devops meetup every second Thursday in Sheffield. Currently not meeting because neither of us have been really interested enough to do a virtual meeting, but we might do. This seems to work quite well, so we might steal the idea. I'm also the founder of Chaotic North, which is a chaos and resilience engineering meetup in the north of England, but we only had our first meetup in March, and then we've been stunted ever since. So in core, in Sky Betting and Gaming, we look after many business critical applications, including customer registration and account verification, login, deposits and withdrawals of funds, and a whole host of safer gambling tools. And what I'm going to tell you about tonight is the tale of a brave band of knights who boldly went where many sensibly had not previously tread. And on this journey, they learnt why choosing the wrong tool for the job can sometimes be the right thing to do. So once upon a time, in the kingdom of Sky Betting and Gaming, lived a small tribe called Core. There was squad after squad of engineers all working on their applications, all deploying them in mostly the same way, with the help from a powerful wizard called Jenkins. And just for the purposes of continuing the metaphor, there was a chef called Ruby who helped as well. The estate was virtual machines as far as the eye could see, and here is how an application deployment worked. So for this demo, or this walkthrough, I'm going to be using a nearly real application called ID API. A few details have been changed to protect the guilty, but this is kind of like a real application that we do run. So ID API, all it does is checks a username and password against a database. It's a simple service. It needn't be so complex, but it is. And it's the perfect kind of application that can be containerized and made into a microservice. So if you want to make a change to ID API, you have to have a pull request from your feature or bug fix branch to release. There's a number of automated tests that get run against this, and then there's a human who reviews it to make sure it's sane. Once you merge in, there's a sometimes automated, sometimes not automated build of the application, which at the end of it, it spits out a tag. And you can use that tag to continue with your deployment, whether that's automated or not. So I mentioned we use virtual machines to run our applications on. On this example, the application is ID API. So on every server that is running the ID API application, we have a /local ID API code directory. Each directory in here is its own version of the application. So you could theoretically run all the application versions at the same time on the same box, if that's how you wanted to live your life. It'd be a really good last day at a company, I'm sure. So yeah, each individual directory is the application in its own right. You'll see the top three items in this directory are symlinks for current, previous, and revision to deploy. How the deployment works, or worked, is we will SSH onto every box in an automated manner, not manually, and run a script which sets the revision to deploy to a tag that we give it. We make use of Chef at that point and as part of its run, Chef will pull that tag from the Git repository of the code. The deployment will then continue, and it will set the symlink of current to the new tag that we've just deployed, and change the tag for previous to what was previously current. Hopefully that makes sense. So in this example here, we've just deployed version 306. 305 is the previous version, 306 is the current. At this stage, it's not actually live. We need to restart the apps in order for them to pick up the new version, but this is how the main bit of the deployment works. Because we're making use of virtual machines, and it's 2020, we're using systemd. So as an example, in this application, the contents of the app directory is index.js, and the systemd unit file simply changes directory to the application directory of current, and then starts the index.js with Node. This is a Node app. So you see, its working directory is always current. It doesn't use any of the application tags within the systemd unit file. And this using systemd means that in a pinch, we can go on and actually just use systemctl to fix and administer the application if we need to. 12 factors. If you've not heard of 12 factors, it's how your app should be run, how your app should be written, and how it should be run. It's a really useful resource to check that you're doing everything you should be doing to make sure your application is running in a modern, stateless, disposable way. So it mandates things like your config should be in an environment rather than a config file. Your processor should be stateless. They shouldn't be sharing. They should be sharing state. Treat logs as streams. The apps are disposable. They should shut down and start up with minimal time, which basically rules out Java. So in this example, you can see in the /local ID API etc directory, we have a config.json and unfortunately a secrets.json. And as far as logs go, we have in the /local ID API logs directory, we have ID API log, which is the application log, and then nginx access and error logs. All these log files are concatenated. Well, they are scraped by an SSH process tailing the log files, brought into a central location, and viewed from there, which isn't ideal, but it works. I mentioned earlier about using systemctl to manage the systemd unit, the systemd services. We can do that, but we prefer to give developers and those that aren't necessarily au fait with systemd an alternative method for managing them, the applications. So we have ID API CTL. And this naming convention is used for all of the applications that we run. The name of the application followed by CTL. This has the commands that you would expect: stopping, starting, restart, rolling restarts, and status commands. So it can be used the same way as systemctl to a degree. So at this point, after we've deployed the application, we can do ID API CTL restart. It will stop the current running version and start up what's in current. And at this point, the application is live. It was a little rough around the edge, but to be honest, it worked well for what it needed to do. There's a bit of a misconception. I don't know if our reputation reaches all the way to London, but there's a reputation of Skybet being a very innovative and forward-thinking company. And for the most part, that is true. But really, the cloud is not one of those areas where we are forward-thinking, at least public cloud. We've kind of intentionally stunted our own development within the cloud because of licensing authorities and concerns around exactly what we were allowed to put in the cloud and what we were not. And it's easier to just err on the side of caution and not get a massive fine and risk losing our license. So you can understand why we've been a bit cautious. If you want some specifics, I can discuss those, but not on camera. So this was all working fine, and then one day, the King CTO and his court of head of tech decreed that henceforth we would have to work to a cloud native and container first approach. Now this scared people in core because we weren't used to this approach, this way of working, this cloud way of working. And we were scared. How could we symlink a local file on disk if there's no disk? How can we log onto a box and read logs if there's no box to log onto? I mentioned we have the centralized login solution, but it's still nice to be able to log into a box and see the logs on the console, just like our ancestors did before. Now, we'd heard rumors of this magical Kubernetes cluster being built by a crack team even more north than us in core, up in Leeds. But no one was really sure whether it was ready to handle the amount of traffic we wanted to throw at it. Just for context, on our login stack alone, we scale to and often hit way beyond thousands of requests per second. We needed to be sure that what was on the other side of the road was better. The grass isn't always greener, that sort of stuff. But here it really, really mattered, because if people are not able to log into our product, we have no product. Still, cloud first was what we were told. And there just so happened to be a major rewrite of our SSO stack about to start that would be the perfect candidate for a cloud first approach. So there was no way we were getting out of this. What we needed was a bridge. We needed a way for developers to write their applications with a cloud native approach without having to then unpick all that work to get the application live. And we were under absolutely no illusion that all this hard work we were going to do will be turned off at the first opportunity we had to move to a proper Kubernetes cluster. So what do we need? If we want to make it as seamless as possible for developers to onboard and eventually move away from this platform, we needed to make it as simple as possible. We need to handle the release and control of end containers. We don't need to be saying we can only have one container per host. We don't need to tie them down to a specific number. There are applications that we only want one of them running at any one time. So we needed to be able to be flexible in that respect. It means allowing them to just write their logs to standard out and we handle the rest. It means allowing them to just create a metrics endpoint that we then take responsibility for polling and passing into a time series database. They should just manage the dashboards at the end of it. Things like TLS termination and load balancing hopefully is a given that that should be an operational thing rather than anything to do with the application. And unfortunately, we would have to build it on existing hardware. The team managing or building the Kubernetes platform had somehow managed to wrangle all that extra resource. There was no way they would give us that same resource just to bridge a gap until that one is ready. We had to do it with what we had. So we went with Docker, of course. Everyone knows Docker. It's easy-ish to pick up. Because of this, we decided not to go with any of the orchestration platforms that are offered already. So no Swarm or Mesos or anything like that. We just went with plain Docker. I mentioned we use Chef. So the Docker community cookbook for Chef is really good. We had to bolt on quite a lot of our own code onto it, but we had a pretty good standing start. For login, we allowed the developers to just write to standard out. We used FluentD in order to collect those logs from the applications and send them off onto a Kafka topic, which is then ingested by the Elastic Stack and displayed in Kibana. We were really lucky in that another part of the business had just developed a brand new Elastic Stack. So it was perfect for us to load test and put some real traffic through. Application metrics was really quite tricky for us. We went through quite a few iterations before we found exactly what we wanted to do. So we started off with Statsy, which was pretty homebrew. It was an attempt to store Prometheus-style time series metrics, but using graphite, and that lasted maybe a week before we just thought this is not going to happen. So we moved on to attempting CADvisor, which looked good in principle until we discovered that exporting metrics was on their to-do list, not on their feature list. And when we inquired about it, the response was basically, you can have it if you can write it, and we didn't have the resource to do that, unfortunately. We even considered running a additional collect-D container to gather metrics. So we have collect-D running on our VMs to gather host level metrics. We tried running a collect-D Docker container to gather metrics, but that just wasn't quite right. It managed to get to Prometheus, but it just wasn't right. We eventually settled on Moby, and that's worked really well for us. I actually gave this talk previously and just happened to be on the same bill as someone from InfluxDB, and we completely glossed over InfluxDB, and he was quite upset by that. Like I said before, the application should never have to worry about TLS, and it certainly shouldn't be responsible for balancing load and replaying requests if they get lost. We went with Traefik for this. We looked at Nginx briefly, and it was fine, but Traefik has got a lot of dynamic backend stuff, so you can give it a container label and it will load balance between everything with that label, instead of having to mess around with different ports on localhost in order to get Nginx working within the Docker network. So we end up with this Frankenstein monster. And what have we created? So this is an example of the application, two applications running on one host. So two of the same application, I should say. We have Traefik, which is in front of the applications, load balancing between them. Moby is hitting the application's exposed endpoints and sending those metrics out to Prometheus, or allowing Prometheus to scrape the metrics, I should say. And FluentD is acting as the login driver and collating all the logs and sending them off to Kafka. And then we had really the most important decision to make on this project is, what do we call it? Because up until now it had just been called the Tactical Container Platform, but that sounds boring and a bit too clinical. So because this was all handcrafted containers, a few names were bandied around, and one of them that I liked was the Artisanal Container Orchestration Platform, but that didn't really stick. I think it was too long. So we are core. This is our logo. This is the core logo. And we were building a bridge to Kubernetes. So we decided to name it Kubernetes. No affiliation to the ex-Labour leader. I have stickers for Kubernetes as well, but obviously they are up here in Sheffield with me. So see what I can do about that, but they are really nice stickers. So let's now look how we deploy a container in this new land, this new cloud-first, cloud-native approach. Well, in order to make a change, you have the same pull request, review, merge, and build job. Except this time, the tag that is spat out at the end of it is actually a tagged image that has been built and pushed to a central artifact repository. You'll see from the tag names on this screen here, we got rid of the semantic versioning, because in semantic versioning, everything's a patch unless you remember otherwise. This made it a bit more useful to see exactly how long it had been between releases, how many releases we'd done that day. So the tag format is year, month, day, release for that day. On the VMs on the file system, you see we changed from local ID API code to just local code, because it's just an extra bit that needs configuring. Just get rid of that, get rid of the ID API. And the same symlinks exist, so current, previous, and revision to deploy still exist. However, these aren't directories of code anymore. This is just a flat file used as a reference to Chef to know which tag of the application to pull down from the artifact store. In terms of the config, the contents of local ID API etc is now in /opt IDAPI.env. This is an environment variables file, which gets pulled into the container when it's built from the image that we pull down, rather than a config directory. So Chef populates this file, and what it allows for config per application running on disk rather than per host. This does mean we have to be careful that we don't have two running at the same time that are incompatible with each other, but we get around this by removing the whole host from service before restarting any of the applications. And what about the CTL script? Well, Docker CTL, of course. People are familiar with Docker. They use it as part of their development pipelines and their development work. All Docker CTL does is runs different Docker commands based on the control command it receives: stop, start, restart, etc., the same as before. So the only customer impacting incident we've ever had on this platform, touch wood, is when someone didn't use Docker CTL and used the Docker command instead. Simply put, they ran Docker restart and then the application instead of Docker CTL restart. And what that did, it took the application out of service. It took a few seconds for Trafic to notice that one of the backends had gone away. Because Trafic still was reporting healthy, the upstream load balancer from the virtual machine was still receiving requests, and so those requests returned a 500 back to the customer, which is not good. The Docker CTL restart, what that does is, first off, that stops the Trafic container. What that does is it takes it out of the upstream load balancer's active pool, so it stops receiving requests. It then checks. Once the applications have finished processing all the requests that they've got so far, it then stops them, does the update, and then starts them all back up. When the applications have started, it starts Trafic. So there's absolutely zero downtime, in theory. So the big win here really is absolutely nothing has changed. Because we're using the same deploy current and previous symlink concept, we're using a CTL command that matches the behavior of other apps. We could easily integrate this into all our existing deployment workflows and pipelines without much additional work. In fact, it was essentially the same as adding a new application like we do all the time. We just gave it the tag format, gave it the CTL command, and gave it the application name. And what has this given us? Well, developers are now thinking cloud first, which is great. They're building their containers that they were previously using just for testing and development. They're building them production ready, not using random custom images that they found on Docker Hub. They're using environment variables versus config files, and they're writing their logs to standard out rather than many different log files littered all over the file system, which is great for us. And us in operations are thinking cloud first now. We're excited at looking at alternative log aggregation platforms. We've got Elastic at the minute. Who knows what we'll have down the line. Similarly, looking at new and interesting ways of monitoring our application performance. We use things like New Relic at the minute to get application performance metrics, but there's nothing to say we can't change that in the future, especially with the move to Kubernetes. We can look at things like Jaeger and Kelly, and we've had our eyes open to that. Now, the proof of the pudding, as they say, is in the eating. Along with a few other applications, the new login system that I mentioned earlier, the SSO rewrite, is built on Kubernetes, is running in production, is doing high hundreds of requests. And we're now at a stage where the team that manages the Kubernetes platform is ready for us to migrate our applications over. We've currently got a piece of work in flight now, which is doing exactly that. And after that, we can get rid of Kubernetes. And this work to change over from running on Kubernetes to Kubernetes has all been done with minimal resource from the actual squad, the delivery squad that own the service. It's all been an operation-led piece of work. The help that we've needed from the squad is things like, can you add a field index, a field to the application logs, please, so we can send them to a different index, rather than can you re-architect how this application works so we can lift and shift it to Kubernetes if there is such a thing as that. And we're helping to shape the product. We're helping to shape the Kubernetes platform. Because we are one of the larger teams that is putting some pretty high volume applications on there, we've uncovered a few things as we go along that aren't quite right, that need a bit of looking at. For example, the shared logging platform, everything from Kubernetes, everything from the single Kubernetes cluster was going to one elastic index, and that was causing index clashes. So if one application said that timestamp was an int and another application says timestamp was a string, whichever got there last gets their logs dropped. That wasn't great. That's why we added the field to the log file, so we can get it sent to a separate index. So we're spotting these problems, and because we're coming from a solution that we've custom built for ourselves, we know exactly what we need the new system, a new platform to do. And so, in conclusion, is it demoralizing that we built this wacky platform that's just going to get decommissioned and forgotten? Kind of, yeah, to be honest. Especially now that we've given it a name, it does hurt a little bit more. But we always knew this was going to be the case. And what we need to take away from it is that we as a team have engineered a culture shift that's changed the way people in our tribe and in the whole company architect and create applications. And that's really something that we should be proud of. These are my contact details. I'll tweet them out afterwards, so you should only need to notice the Twitter account. If you don't want to ask a question now, then feel free to reach out to me on any of those platforms. I'm going to attempt to go to the chat box, but I don't know if that's going to stop sharing my screen, so bear with me.